So this should be on. Yep, good evening. No one's here yet, but that's alright. Oh, 2 people. Cool, 2 people, hello. I'm sure there'll be a couple more joining us. So, I've got here a, this is what I intend to do. So, I want to explain last week's bug. We ended last week where there was a bug in the interpreter. I thought it was initially in the garbage collector. The garbage collector was returning values that used the high 64 bits of values. So they were higher than the 32-bit value could represent. That's because that's what mmap gives us. And some code in the boxing and unboxing and tagging of values wasn't handling that properly. So I want to show that first. And yes, here I am. So what we had here, this is one of the built-ins, and what this C function does is builds up a plasma bytecode function. Not really a function, more it's a word. It's more like a 4th word that well, it breaks apart a tag and gives you back. So you start with a tagged pointer and it returns a pointer and a tag, but we load this before we start the interpreter by telling the interpreter that this, when you need to do this is the set of instructions you need. So what we've got is the first instruction is write a pick instruction, which will take the address, it's like dup, but because we tell it 0 here. The next instruction is load an immediate number. Here's where the problem was. This loads a 32-bit number. We were loading a pointer number like PZW pointer here. We did have that here to load a pointer-sized word from a 32-bit word, and we were expecting PZWrite instruction to take that 32-bit value and grow it out to 64 bits and do sign extension when it did so. But this function, the C function that puts together the instruction stream, doesn't do sign extension. It only does 0 extension, and so things weren't preserved properly. And so yeah, because this is the mask, and so then when we operated using that as the mask over the actual pointer, PZI and, so we're anding the mask and the actual pointer value, which we've got on the stack already, to try and get the pointer and its tag separately. But when we do that with something that was all 1s and then got 0 extended, so now it's got 0s in the top, we're actually dropping that half of the 64-bit address of this pointer. So it wasn't. So then, when after separating it from tagged pointer into the pointer and the tag, the pointer itself would have the high 32 bits stripped away. So the solution is just to add an extra instruction, because right now, rather than go in and change this, which, and that's a bit of what you call it, technical debt, that I should eventually go and change this so that it works properly. But for now, what we do, if the machine word size is 8, so if we're on a 64-bit machine, then add an extra instruction which takes the 32-bit value and gives you a 64-bit value using sign extension. So sign extend 32-bit to 64-bit, and that's all that's needed to fix that bug. And so now we have a test case that works. Right, and what I'm doing each week is working in the same branch and not modifying it too much between when I stop recording and when I start recording again. So to try and give some consistency. I don't know if that's cool or not, or what people are after, but that's the idea. So, and so between this time, I did do a little bit of work. Let's see. switch to full screen mode, which should be this, you should see all of my GITK window to see all the history. So here's our branch here. We've just, in fact, there's only one thing on here. So last week we fixed these, what did we do? Use no optimizations, fixed pointer tagging. This is our bug fix. So like I said, it adds like makes that 32-bit value rather than a pointer. Yeah, I should have just shown this. This would have made things a bit clearer what had actually changed. I added a define to the make file so that we could use the mmap system call. And now those went onto the master branch, and now we're in the GC branch to work on the garbage collector. And so last week I committed our two files, bzgc.c and bzgc.h, which have our basic garbage collector in them. And so now we're going to work from there. Meanwhile, during the week I went and did other work, so blah blah blah, other work. But in these streams I'll try and stick to one branch, at least for now. So yeah, so we set up the garbage collector. What have we created a heap structure with the base address of all our heap and the current allocation, the pointer used to allocate from. There's our setup code and our call to mmap. And yep, and then we initialize the structure and return it. When we free something, that was fairly easy. Oh, sorry, this is when we free the heap. So we call munmap to unpack that and then free it. Technically, we could just terminate the process, but this is a little... It's handy for debugging if you unpack things, at least in debug builds. So I actually should if-def some of those things, but I need to do that across the whole runtime. So that's actually... I don't mind for now. I'll fix it up later. And the allocation code right now takes... If we want to allocate a cell, we take the current heap pointer and then advanced heap, the heap pointer based upon the size of the thing we're allocating, and round it up to the next machine word size. So a line up will round up the address to the next highest machine word size, so that we're always giving rounded off values, and then return the cell. So it's a really dumb bump pointer allocator that does not allow you to free memory. Couldn't possibly allow you to free memory right now, and or to collect memory automatically. It doesn't support anything like that. So, question: as long as you're not messing around with other parts of the code in that branch? No, that's true, I'm not. I'm only working on the GC in this branch. If I do something special to another part of the code, I'll show you, like I've done just now, because I hadn't committed those at the end of the last episode, so I did want to show that. So, explain last week's bug, we've done that. A quick refresh of the GC, we've done that. I want to write a test program that exhausts the memory and make it crash, so that we've got a program to check that we're actually doing, so that when we do implement garbage collection, we can test that it works by having a program that just tries to take up memory. So first what I'm going to do, open my garbage collector and check what the heap size is. Okay, right now 1 megabyte. That's fine for now. What I want to do also, before I write such a program, is maybe provide a way that programs can set parameters of the runtime, like the heap size, so that should they want to, they can lower the heap size, then run their test and then exit. But while other programs get the nice default heap size, which should be plenty for most programs. So, in fact, 1 megabyte's tiny. We'd actually allow it to grow in the future, but I'm not going to do that for now. For now, we just need something simple to test with. When we get to a later stage of the project, we're going to have to allow it to grow at certain times. So if I want to be able to set parameters, I need to actually store the current heap size in here, allow us to mmap new memory, and allow the runtime to set that. That's actually a good thing to do for this session. So I'm going to go off script. I wrote that agenda and now we're going to go off script. Was the book... So Gert has another question. Was that book you read on GC helpful? Or did you know most of what you needed to know? No. How do I admit this? Before I read that book, I didn't know that much about GC. And now for my job, I work on a garbage collector. And so it would be fair to say that I owe a lot to that book. I would highly recommend it. And it's really well written. It covers a really interesting topic. Okay, maybe I find it fascinating, but you know, whatever floats your goat. It's really well written as well. I found that I read it cover to cover. I haven't ever read a textbook cover to cover before, so that was pretty great. That is the Garbage Collection Handbook by English bloke, Richard someone. Anyway, you'll find it if you I think it's gchandbook.com. So so Gert's saying he hasn't found a practical use for it yet in his line of work. No, I don't imagine that a lot of people will. I was interested in writing the plasma garbage collector. I already knew I suppose I did. I knew a bit, but I knew a lot more after reading that. Reading that book helped me understand the Bohm garbage collector, which I've read about before and read the source code of before, but I understood it in a lot more depth and was actually able to begin modifying it from that point after reading that. So, So we want to be able to set parameters. Actually, let's start here. Why not? Base address void. If I realloc memory, something very interesting could happen, but we'll see. We'll get to that later. Oh, I know what I'll do. I'll do something else. Something else a little bit tricky. I'll show you later. GC max size. So we'll keep the same maximum size. We'll still malloc that much I'm telling you now, but I'll show you later. But our actual heap size will keep smaller because not all of this memory will be committed yet. That means it won't be actually taking up RAM of the system. It'll only be ready to go when we touch it. So we try and avoid touching it until we need to. Meanwhile, heap size is something else. Let's start with pzgc size. Max. Some more descriptive names. So we're making two changes at once. So I'm going to show you something funky in Git that I like. PZ GC heap size. Should be initial heap size or default heap size. We're going to set it to 4096, one page in most operating systems. We should actually be detecting that at runtime. We can detect it at runtime or compile time. Runtime's probably a little smarter. And we could even make it, we'll keep it there for now. And we might even set parameters later. It's just an easy thing to show on the live stream, that's all. So, yeah. Max heap size, because what's at the size of the heap? We should tell the reader of our code that. And try and wrap it 78 or 76 columns if I can. Let's see. I renamed these fields while I was talking. And yes, this is very much unscripted. I don't, particularly the code itself. I don't have time to make a scripted stuff that actually make this good. Yeah, okay, I don't need that one. No. Press the wrong button. Okay, make test. Yep, that's fine. Good. Okay, I'm going to show you something with Git. Just check for questions. Okay, yeah. Yeah, my stream may be glitching. It's it is tricky because I am on limited bandwidth. I can just barely manage this. I'm just going to check that that message wasn't relevant. One sec. Oh. That's the right one. One sec. Yep, nothing biggie, just a message from my partner to say this is the anniversary of the day I proposed to her. This is nice. I'd forgotten. We don't usually track those dates. But we know, I don't know how we know that actually. Because it's not like we had Facebook back then. We definitely didn't have Facebook back then. Anyway. So, that's right. I was going to show you something in Git. So, I want to add incremental. So, I've made two changes and I want to separate them out. So, I'm going to say add, sorry, not incremental, interactive. So, add-i gives me interactive. Yes, I want to choose some patches, which is letter P or for patch. Choose this file. Yes. Okay. So I want to separate that renaming of some of the variables. So I actually want to, I can split the first thing because there's two different changes here separated by some unchanged lines. I can split them into sub things. So I could just say yes or no to this one, but I actually have to edit this one because I don't want to commit this line. I just want my variable renaming. Quit. And here again, actually I do want to no, I don't need that second line. Those last two lines. So edit, E for edit, remove those. I should actually change heap pointer as well. So what I can do, I'm just gonna say take out that line and add in a new line, which is the same. Oh, what I'd really like to do is that. That would be smarter. Yeah, so it's a little bit weird. I think I just want to accept this change. No, I want to accept the first half, so split and then yes, and then edit, and then delete that one, save. Now I do have a white space error, but I can fix that separately as well. Yes, see, one line adds a white space error, which just means that there's some trailing white space at the end of a line. But meanwhile, I can git commit and choose some better variable names in the GC. Here's where I could shout out to Livestream audience members. But I closed the window and can no longer see the chat, so I'll fix that very quickly. So you should be back. Yeah, so now I can say as above. Because, yeah, that's all I do. Yep. Great. And now I still have git stash. I want to fix that white space. So I've stashed my changes. I'm going to say runtime pzgc.c, trim the white space off the end of that line with a vim macro that's in my vimrc. Make test, let's just make sure. Add. Check it again. I like add anyway, even if I know I'm going to commit everything, because then I can at least see them and check them one by one. So it's one of those checks that you do before you actually commit or push. So yeah, so I've done that. That fixes the white space error. Git commit amend. Yeah, git stash pop. All right. And that'll do for now. Yeah, so now I'm just going to check the chat on. When I move large positions on the screen, it does weird stuff. Okay. Alright. It's weird when the screen that I can see lags a little bit, and so I can't actually see my face in it right now, because obviously back then in time I was reading. So yeah, so it's weird that I wouldn't be there. So, do we want to add a way to send parameters or a way to detect? Yeah, I'm more confident about that one. Let's do the one I'm feeling confident about. So if we want to set a parameter in the garbage collector, let's add some new functions here. Runtime pzgch. Void or bool? Void for now, we'll fix it later if we need to. Set max heap size. exporting a new function from our module. We'll define it here. We can just copy this. Remember to take the semicolon off the end. And so what we'd like to do, although I kind of like to do these sometimes the other way around. We'll start here just because we're here. What I want to do is, if new size is, what we actually have to test is the high water mark is less than heap pointer. Right. If we're trying to set the new size to something that's less than where the heap pointer currently is, then we need to, then we can't do that. So we just, for now we ignore that. We'll consider that these parameters are advisory. We should possibly, depends what we want later. It doesn't actually matter that that's not throwing an error. Because the only people using these APIs will be people like us. Like the implementers. As long as we document it. Otherwise, it should be totally fine to set the heap size. So heap size, new size. And there'll be some edge cases to detect, but we'll find out later. Hey, living on the edge. All right, runtime. We need to, I want to go back to the, not thinking, or typing and thinking. Runtime easy run.8. Because we should document that behavior. And since that's actually implementation defined behavior, let's describe it differently. Let's explain what it does in the ideal case. Set the new heap size, period, new lines. Note that if the new size is less than the current size, it may be difficult for the GC to allocate to won't always silently fail. There's no reason why we couldn't compact the heap. But it depends. We just leave that as implementation defined. So yeah, maybe it should return bool. Let's do that. Yeah. There'll be other alignment constraints. Maybe we should measure it in machine words rather than bytes. All that kind of stuff are all other choices we could make here. And wrong button. Our style manual allows us to put this all on one line since it's just a return, so we can do that too. That's should be fine. A warning. If the new size... Oh, of course. What we actually want to do is heap pointer minus heap base address, because that wouldn't tell us the size. So we're comparing 2 pointers. Let's double check the types of those. They are both void pointers, which means they're measured in bytes, which means we're fine. Not all pointers, when you do pointer arithmetic, use the same units. So, but void pointers are measured in bytes. Usually the pointer uses the units of its type. So, that's the next step. We want to call this from the runtime. The way to do that is to add a new instruction or a new built-in for setting parameters. I'd rather not add too many new instructions for random things, so I'd prefer to make this a built-in, which means we need some magic constants as well. So let's take a look at how we set up new built-ins. I'm going to use top-down development. This is where you start from what you'd like and you just begin implementing it, assuming that the lower level details are already available, and as you find you need them, you fill them in. So it's kind of nice. I'd heard of it before, but I didn't actually see it until I watched the SICP videos. And then I'm like, huh, that's really cool. And then I explained it to somebody that said, yeah, top-down development. I'm like, oh, okay. So that's what we're going to do. So, which means I'm even going to go back up a little further and use test-driven development, which means we'll write a test first. So, okay, the stream is continuing, so we should be okay. But yeah, that glitched out for a bit. So I don't know how much everybody missed. I was about to set up a test case, but I wasn't sure if I should do it for the runtime only or test the whole compiler for options to set the heap size. I might start with the runtime. Yeah, I'll do that. And try and keep things self-contained in the episode. No, let's go the whole compiler, because that lets me show some Mercury code. I've done several episodes with C code. Let's do more. This will get us showing and demonstrating more Mercury code. Which will be cool, and plasma code itself as well. So push the tests valid. So let's call it. These are all our valid tests. So they're tests that are supposed to succeed when we run them. I'm going to copy the die test, and call it set parameter. Yeah, so here I am. So now we're looking at some plasma code. I forget what my style guide for plasma says I should name modules like. I think it might be that. Or am I supposed to have an underscore? Let's see. Alright. We only lost 15 seconds there, so we probably didn't lose anything of significance. So, let's look up the style guide. So, or the documentation for the Plasma language. Plasma language reference. And what I want to look at here is a note on case and style. So I want to look at module names. How have I said, okay, they should be like this, upper camel case. And there's all reasons for that, because the Lexa will actually use the case of the first letter to distinguish between different types of symbols. For example, types and type variables. So, yeah, so module set parameter, that's fine. Let's go back to single screen mode. And oh, and we got to see my web browser there. So if you're wondering why it looks different to yours, I have some settings on to make it more readable for me. I've mentioned before, but I'm probably going to mention each episode I use it. So I want to do set parameter. And for now, let's use strings for our parameter names. So what I'm doing here with this top-down development is I'm saying what I want things to be like, and then I'll actually implement them. Because, yeah. Yeah, so built-in set parameter. Let's pretend that there's a function called that. Do functions have underscores? Because, yeah, I forget the language that I'm actually writing in. So function names first letter log. Yeah, like that. So set parameter, gc max, yeah, heap size. And let's say in this one, we set it to 3. We're just trying to see if this call succeeds for now. That's no longer relevant. And that's our test case. Actually, well, let's test. We can test that it returns a result. Set parameter should be side effecting. So let's say result 1 set parameter. It's going to need a bang there. Because it's going to use the IO state. Although we won't see the declaration because it'll be defined in the compiler because it's a built-in. I do have true, or is it lowercase true? I think it's uppercase true. Yes it is, because I picked the Haskell style. Yeah. True, that's fine. Actually, this is the error case. We should use a match statement. Match res1 case true. Res1 string. Chat window back so I can see if people are asking me something important or telling me that my stream's gone away, which they're not. So let's switch back. Cool. And while we work on actual Plasma code, top one string. And that's actually the case we don't expect. We shouldn't be able to set it to 0. Now let's test. Let's do another very similar test. I don't mind a bit of copy paste. Print, bang, there's one. No semicolons at the end of lines in Plasma. It knows the end of a statement because the next token will tell it. It's like if this was an operator here, where my cursor is, then it would know that this statement continues, but since it's something else, then it knows the statement has to be terminated. So we're designing the syntax so that we can avoid that. Let's, yeah, 096, that's going to be safe-ish. If it's not, we'll find out in the future when I break that test, because I make some other change, and that will be fine. And print, bang, res2, string. And that's your first Plasma program on the live stream. Let's see if it works. Make an expected output file to get so that the test case knows, the test suite knows about it, and make set parameter test. Line 12, a syntax error on line 12. Red ident upper expected right arrow on line 12. Red ident upper, that's this token, expected the right arrow. Do I actually have the case keyword? Let's check the reference manual again. Yay. If I had a second screen, I'd have a nice way to switch screens without revealing too much, because I just don't need to reveal the YouTube screen or anything like that. Okay. Let's see, abstract machine actually. Yeah, this one was in before. What am I looking for? The case statement. Code statements. Assignment, Where is function call return? Pattern matching. Yeah, okay, I don't use a case keyword. That's right, it wasn't. Because it wasn't necessary. So let's try that. Line 23, another syntax error. Oh. Just do that. Oh yeah, duh. That's me not thinking. Alright, unknown symbol, set parameter. Good, that's what we wanted to see. So right now, some of the compiler errors, like the ones before, gave you line numbers and a fairly okay-ish output. Some of them throw exceptions and just rely on the exception handler to break apart the message. And so you can only ever get one of them at once, and one of them is unknown symbol, so it just throws an exception and tells you the location in the compiler where you need to put a better error message. So let's make a set parameter built-in. And do some Mercury code. Now that's a nice comment at the top of the built-ins file to tell you the different types of built-ins we can have. What we're going to create here is I think it's a foreign built-in. These mostly cover operating systems, so yeah, they're usually located in PZ run and are transformed when the program is read into the opcode that will cause the C procedure built into the runtime system to be executed. The specifics depend on which PZ run file is used. Yes, this is what I'm intending to use. So we need a foreign built-in for set parameter. Let's look at how I've defined some of the other built-ins. Yes, MISC. This is the kind of thing I want. And yep, free. Bool to string, int to string, and print are some of my built-ins that I've got already. I can add another one of these like this. Snock is like cons but backwards. For, in this case, qualified names. Q names are qualified names. So built-in module name is already a qualified name, and we're putting a string on the end of it. So rather than consing it onto the front, we're snocking it onto the end. Names are bad. And set parameter. So register the built-in function has I don't know why we're repeating the name like that, but I suppose that's an unqualified name there. Function int built-in. So this is calls a constructor. Is as a yeah. So set I know why. Because this name is the name that appears in the environment, which is a runtime construct for how things are looked up, whereas this name is the actual name, and it gets put into the into a different part of the compiler. So it's inputs. So what I'm doing here is I'm using this function and passing the arguments. So the next argument is the list of inputs. This takes a built-in type, which is a string type, and a built-in what are all my built-in types? I assume I've got string types. Built-in type, int, yeah. I couldn't remember what I called it. And the return type is a bool. Bools are not built-ins, they are something else. They are here, bool type. I thought so. We pass, earlier in this function we define the bool type and then we pass it in as an argument into here. So I can just say bool type is the single return type. The square brackets mean a list in Mercury and in Plasma. Set uses the IO resource in the user's position and an empty set for the observed resources. Then, what are the other? So, because I'm remembering some of that from memory, which is why I know what to put there. The register built-in function also, so we've given it a function. It gives us a function ID as a return parameter, which I guess we don't need right now. None of the other code here seems to need it, so maybe we don't either. And we give it the the map of built-ins from qualified names under built-in items, and the core. And those are threaded through things. So they use Mercury's state variable syntax. Bang map and bang core. Comma to end a goal within a conjunction in Mercury. Yeah, Snock, really. It's a terrible name. Now I'm responding to the comments on YouTube. Yes, Snock is really what that's called. I've called it that because I copied a terrible API within Mercury itself. Yeah, cons itself is a terrible name because it's an implementation detail. Cons coulda... Oh, well, cons actually isn't. Cons is short for construct. But coulda and car are terrible names because they refer to implementation details. They're all things that we should move away from. So yeah, feel free to name it something else. To submit a patch to the compiler to rename that thing. I'll show you where it is. In qname.m in the source directory, you can rename Snock here. So and submit a pull request. So we've registered our built-in function. I think that's it we need to do here for the compiler, because of work I did a couple of weeks ago to make it easier to set up built-ins. Yeah, because this adds it all to all the correct places. So register built-in function will tell the compiler it gets a function ID, sets the function within the core representation, so for later other things to refer to and type check against and all of that stuff, and inserts the name with the function ID into the map that we're building up. And that map is what gets used to resolve names during the initial parts of compilation. So I think that's actually all we need to do in a compiler, which was simpler than I remember. Probably because I did that earlier work. Test. Well, actually, let's go to our test, this particular test case, and see what the... Oh, mate. Duh, we need to rebuild it. And you get to see more Mercury bug fixing. Bool types is a common type ID, but... Okay, I can show you that. 372. 372? Yeah. So the problem here is that bool type is a type ID, whereas we want whatever type... Well, actually, I'll show you how to look it up. Look it up on the function that we're calling, and its parameter is a list of type underscore. It's only got the underscore there because type is a keyword in Mercury, so we put an underscore to avoid that collision. And what we've actually got here is a type ref. This is our boolean, where we're referring to an existing type. The other types that you can have are built-in types, where type refs are user-defined types, type variables, and function types, which is another way to construct types out of other types. The way type ref is a way to make types out of other types. Its parameters, mainly. So refer to the bool type elsewhere, and it's asking us in the above window for a list of type parameters to give to the bool type constructor. Bool doesn't take any parameters, so we give it the empty list. And let's break our line there so that we keep this entire thing on one line. And that's a little neater. Save, make, test. Let's see. Oh, look at that. So the reason why so many tests are failing is that now the compiler is writing in its bytecode files, hey, I expect you, Mr. Runtime, to have a set parameter option built in. And the runtime doesn't know about set parameter yet, so that's what's failing there. So, whereas here, oh, it's still unknown symbol, it's set parameter. Have I spelt it correctly? No, I haven't. Hands up in the live stream if you saw me make that mistake. Were you paying attention? Yeah, prepend and append would work fine for replacements to cons and snock. Yes, we should get a different error. Right, so now the compiler accepts our program. Let's actually, I'm going to touch set parameter P, which is the source file, run make, and you'll see it now runs the compiler, plasma C, on set parameter, and gets the bytecode output file and attempts to run that with the runtime, and that's where things fail. Procedure not found, built-in.set parameter. Yeah, with the amount of bandwidth I've got, the screen may be too blurry. In 2019, I might get fiber. So I have DSL. At the moment I have about 12 megabits down and about 600 kilobits up. So I wonder if I turned the camera off, whether I'd save enough bandwidth to make the text less blurry. I should try that for next time. But everybody else puts the camera on for live streams, so I thought I had to as well. Yes, I'm using had to in jest there, because there's no rules. Right, so I want to change the runtime now. Before we do that, let's commit our change to the compiler and because that's probably a fairly self-contained change. But we'll end up merging it with other changes anyway. So I won't put a tag there, so I know I need to merge it with other changes later. Declare set parameter built-in compiler in the compiler. I'm going to copy this because when I end up merging it, that's going to make sense. What else have I got? Oh, when I said 2019, I don't know when in 2019. Yeah, I suppose I should keep the camera because it's personal. That makes sense. I might make it smaller. It might save a tiny bit of bandwidth. This might be why I have hardly any viewers, because so little bandwidth. I could record these ahead of time, but then I wouldn't get the questions and that wonderful connection with the audience. No, I don't actually want to commit anything from the collector yet. Not until I've edited a bit more. So right, I want to add a built-in to the runtime. So we add built-ins here. So yeah, so it looks like this creates a module and adds several built-ins. Right, and these look like the right type of built-ins to add. This is an API I created earlier. Now, we don't do any type checking at the bytecode level. In fact, we don't even do any sanity checking of code we're reading in. So you could get really interesting things if you give it random stuff. That looks like a symbol I need to define. So let's go to built-in die and see what we're doing there. Take a look at the type of the structure. So we're setting, that's creating an instance of a structure, and here's the structure itself. So an enum for what type of built-in it is the first parameter. So it is a C function. And a union, which means we only should define one of these, and we actually, the new versions of C allow us to say which one we're defining statically. If you're not clear on what a union is in C, it's like a union in any other language, except it's undiscriminated. It's not typed. It's not checked which member you're looking up. So, but these two things, bytecode and C function, share the same memory, and which one you want is just which one you read or write, and C won't bother to check it. So built-in. So this is the function that actually implements our built-in, which we'll go and implement in a moment. And does it need to be freed? No. No, it doesn't. So this still won't compile. Yep. Because we haven't defined that function yet. Let's go take a look at that. We put those in runtime c pz run.h. And so yeah, there they all are there. They all have to have the same signature. And what this signature means is it passes the built-in function well, let's take a look at the parameters first. Set parameter. What'd you do, Vim? Avoid a reference to the stack, which in this case is a totally opaque thing because different runtimes might use their own stacks. Their own layout for the stack. So in this case it's opaque, and later on we cast it to whatever stack our particular runtime uses. Because this is meant to be modular so that I can plug in different interpreters. And it also puts in the current value of the stack pointer. This is the expression stack, by the way, not the return stack. That isn't needed. And it returns a new value for the expression stack pointer, so that you can return items, you can add items to the stack, and that's how these communicate. Yep, and it fails to link because our runtime doesn't have that symbol. We've only declared it. I do like to run the compiler a lot. So yeah, so we've only got one interpreter right now, the generic interpreter. We'll put our new built-in next to this one again. That doesn't hurt. And right now, let's just return. We'll pop two things off the stack, the two parameters. Oh, we need to return something. So we'll just make sure that the stack point is aligned and we'll see what happens. Make test. So most things should run, except for the set parameter test, which when we run it, I'm going to run it by hand. I need to compile it because make has helpfully removed the intermediate file. Segmentation fault. I wonder why. Yeah, it's not going to help unless I have line numbers. We saw this last week. I mean, it shouldn't actually, because it's returning a bool, so I don't see how this could segfault. I know I haven't finished implementing it, but it still shouldn't segfault. On the expression stack. So dereferencing the expression stack has caused a segfault. How? Let's turn on tracing and try again. Program again. So ESP is 5 if I do. The stack mustn't be aligned. I'm not sure on that one. Expression stack minus depth gives us, yeah. What are we executing? Roll. We're coming off the end of the stack during the roll instruction. load a data pointer. Let's look at the disassembled at the text version of the bytecode. So I've used the dump stages option of the compiler, which gives me a whole bunch of files, which are pretty printed versions of the program during different stages of compilation. How are we going for time? It's nearly 10:30. I don't know when I'll finish up. I would have liked to have finished this. Was something that was almost finished. We'll see how we go. So I believe we're still in the main function at this point because it looked like the call stack had a 0 depth. But we were rolling over 7 items. There. I'm doing that at the end of block 1. So is that a bug in the compiler, or did I really just mess something up? Because of course the stack will be misaligned if I get the type information for this new built-in wrong. Or am I hitting something in the compiler that I just haven't exercised? So and it occurs to me that my blocks aren't linked very well. They're just out of order. It doesn't actually matter, but it's something that other later stages of the compiler will take cues from, so it'll be something to fix up later. So if we roll over 8 items, oh no, we are. Is this after the first call to print? It's the very end of the program, and it's trying to, the fix up stack code at the end of each procedure tries to reset the stack pointer to the right position and put the return address there. So yeah, so this is the end of the program. We've got here, this is our return value. Because we're bad at stack manipulation, we duplicate it on the stack and then do a bunch of work to take the other things off of the stack from underneath it that we littered the stack with. There'd be much less of those if we were better at stack manipulation. There's a reason why we're not, but never mind. I might have to get back to you on this one because there's a fair amount of head scratching involved with debugging this. It does look like there's a yeah, the bowels of the runtime. Well, Firefox, stop doing that. I don't want to update now. Yeah. What if I do that? Do I get really horrid results? Because that can't be right. Well, that crashed as well, but it looped for a while. What was going on there? Or is it just noisy? Succeeded to set heap size to 0. It's doing... Have I done something dumb? Well, there's one thing that's done. Yeah, Gert says, and he has a really good point, I'm glad to see that programming is the same for everyone. Looking at errors, scratching your head, going, aha, fixing, repeat. This is very true. Like I said, I've got a friend who's just beginning to learn programming, and she was relieved that it felt the same for her as it does for me as well. But yeah, it's just different errors or deeper errors, but it's the same basic experience. I'm fairly sure. What if we simplify things and only have one of these? Let's comment, yeah. See, that did not work well at all. There are still items on the stack here, which the runtime should have an error for. Let's implement a new feature in the runtime. Yeah, this is... What should be the level of the expression stack when we end the program? We'll try this with a working program as well. So we'll implement a new feature to throw an error if the expression stack is not aligned when the program ends. So make hello.pz runtime pz run hello pz. The expression stack is 1 at the end of hello. That doesn't look right. No, that's right. Did I add in a buffer? I don't know why that's right, but I think the expression stack starts off at 0. There are 0 items on the stack. But then why, when we print state, do we see an extra value? Start ESP. Yeah. Start is greater than or equal to 1. Because we should do that. So there's a different bug that we've fixed in the printing of stack. So if we run hello again, right, now we see only a single value on the stack when the program ends, and at the beginning there's no values on the stack. So that is absolutely correct now, and less misleading. So there was an off by 1 error there. Let's commit that. So that was a whole different error that we fixed. And it doesn't actually help. Oh, it's in trace. 7. Fix off by 1 error while printing. Right. So 1 bug fixed, and off by 1 error. So that's progress. What have we got next? We're still... So we expect the stack pointer to be 0. So what happens if we do if ESP does not equal 1, sorry, we expect it to be 1 with the single return value on it. Then printf stack misaligned ESP is that should be 1. Make test doesn't work very well when we're tracing because it generates far too much output for some of the tests and will fail a whole bunch of them. Anyway. Stack misaligned ESP is 2 expected 1 for which parameter? Set parameter, yeah. Whereas hello.pz works. So set parameter doesn't, we have a misaligned stack. So my hunch was correct that there was a misaligned stack, even though we'll see that's returning the wrong value. If we return stack pointer -1, we should get the right situation. Well, if we compile our program and then test it, we should get the right answer. And that's working now. Why didn't it work before? Why did it crash before, but not crashing now? What's going on? Interesting, we have a new failing test. Once since adding that check-in. So, I wonder what's going on there. PZT mutual. Oh, it's probably my fault. Well, it's all going to be my fault. But what I mean is, it's probably not the compiler. It's probably the bytecode program that I wrote. Anyway, sorry, we do want to run that one. Set parameter, make set parameter. PZ heap size. It's printing the wrong strings. No, PZ is not a string. It's printing. Why is it printing the string heap size? That's being miscompiled. This might have to wait until next week, because that's weird. Dump stages. No, not on that program, on the compiler. Yeah, it already did it. Dump. Let's have a look at the, this is the intermediate, or the core representation from within the compiler pretty printed. So, let variable 8 be heap size, variable 7 is 0, call set parameter with variable 8 and variable 0, and let that be result 1. In that, let v1 is result 1. Result 1 string is v5, yeah. 6, yep. So let v4 is result 1 string, and we call print with v4. Right, that makes sense. So that's correct. So, the next step to solve this is to start emulating this by hand or to reduce the complexity of the program until something pops out. But it's after 10:30. I don't want to make these things drag on forever and ever. That's 1.5 hours. I might leave it there. But I'm not going to remember where I got to next week. And what's up. Well, at the very least I should commit what I've got. Well, push what I've got working, which is a couple of small things. No, git stash pop. Well, now the other one's working. What's going? I don't understand. Oh, I know, I do understand. Some of my test scripts don't capture the outputs of things properly. So that other one that did fail before isn't failing now. Because it still is failing, but the failure's not being captured. So yeah, there's a bug in the compiler. This is unimplemented yet. Let's see. I think it's in the compiler. I don't know yet. So let's just start from here, looking at the code we've written and committing what we can. So we've started to add the new built-in to the runtime. Set parameter. Yep. That's the new built-in there. It's also in 4 and 5. Not that part. That's a separate patch. And 2 and 3. We'll actually leave that. I'd rather leave all the actual GC changes until later when we know that when we've got them linked up. Maybe something. Hit diff staged. So what I've double check what I've selected. I think I've only selected adding set parameter. Yeah. And this is work in progress. It's something I haven't finished. And the reason I'll commit it, and when I rebase, I'll move it around and I'll work on it further. Add the set parameter built-in. You know what? I can make it do absolutely nothing. Well, I've got worse than that now, but I can make it actually say that it fails for everything. I'll do that in a bit. I can do that now. Well, so what I would... no, I won't do that now. I can't be bothered. I have a cold at the moment. I'm getting one. Which is why I'm tired too. Git commit, yes. Raise an error if the stack is misaligned when program raise an error if the stack is misaligned when the program ends. Now I won't actually push that now because that's causing one of the other test cases to fail. It could be a simple fix. What else have we got? The GC things. And like I said, I wouldn't commit them, but what I mean is I won't push them anywhere yet. I'm just going to make it a commit. Add set parameter maximum heap size for GC. I'll change it later. Git check out make file. So now I've got a clean workspace with everything committed as separate changes. So what I'll do, switch to full screen and open GITK again. So you can see what we've been committing. So here's where we started with tonight. We started on this patch. So choose some better variable names for the GC. That's good, that's solid. Let's keep that change. Declare set parameter built in the compiler. That's fairly good, but I want to merge it with something else. Right, so what we're going to do in the terminal is git rebase interactive. We need a point to leave off from. It's origin GC. And x make test. So we're going to execute make test after applying each patch. So choose some better variable names. Declare set parameter built in the compiler. We're not going to do that tonight. But it can be merged with another one. Fix off by one error while printing the expression stack. Yes, we can do that tonight. So we're changing the order of these patches so that I can push some of them. Declare set parameter built in the compiler. Yeah, sorry, we just looked at that. Add set parameter built in runtime. Those are the two I want to merge. Squash. And check the stack at termination. We should be able to fix that. That's the one that's got a failing test. If that works, yeah, I'm gonna take a quick look at that. And yeah, and I'm going to remove make test from those. I'll just make it, see if it can build them. So the idea is it'll see if it can run the test suite after applying each patch that I've made, and for these ones it'll just see if it can build them, and I'm not going to attempt to push them tonight. So, one compilation error. Separate. We never committed that. Git add I, add untracked, set parameter, 14 and 15. We never actually committed our test suite, so it wasn't arranged in the patch stack. It was just there. So add new test, add set parameter test, and we'll just commit that there and continue. Git rebase continue. Yes, that's fine. And that's the one where I want to fix something of. I want to fix the mutual test. So what is happening there? If it's not too difficult. If it's tricky, I'll leave it for later. Make test. Well, that's the one with an off by one error. A stack error. So look in the code. Stack misaligned, expected 0 should be 1. It popped too many things off the stack. Just by 1. Right. I think that's all it is, that there was no return value specified in this test. Built-in print even block, not block. Wait. Block entry. 35 is odd. If conditional jump to... Yeah. The rest is probably okay. But I'd have to actually go through it by hand and check everything. I probably did the right thing when I set it up, except for forgetting to return 0 from the main function, from the main procedure. And this is, yeah, this is the bytecode. I hadn't explained these files yet. PZT file is a text version of the Plasma bytecode. So it just allows me to test the runtime system without involving the compiler. So make test. Yep, we're nearly done. So I want to do that again because there's that extra patch that shouldn't be there. There's this one here. I'm going to add the test case as the last thing to test. These don't need it. I'm going to run make test just to make sure, and exec make git tag ready. And I'm going to mess around with Git a little bit. Continue. Oh, because I've got one extra. Yep. That's fine. So what we've got now are these 3 patches, all on the GC branch. Got 1, 2, 3 patches to push tonight, which make things better, and they're just going on this branch. They'll get merged into master eventually. They could get cherry picked off here, but yeah, I would normally do that if I was working in a bigger team or something, and other people might want those changes sooner rather than later, because they're not strictly garbage collector related. They're just runtime fixes. Okay, so I'm going to make a new branch. Git branch gc dev. because it'll be where I do the GC development from now on, and I'm going to move this branch back 3 places, so then I can just push it. Well, actually, hit reset hard ready. So I've moved the GC branch back to here. Oops. Back here. And so now I can just push these 3 things. Git push GitHub. I'm going to move them to my own GitHub, because I've got a copy there at a different URL, which is where I was putting some in progress things. And another copy on my local machine. And we're done. And that's everything for tonight. I hope that was informative. Sorry we didn't get a thing finished, but yeah, see you next week.